Hi everyone, I'm Jan-Kevin Gilmarin, a graduate research assistant from the Department of Civil and Environmental Engineering at the University of Maine. Today I'm going to present to you the research that I'm conducted with my advisor, Dr. Ali Shirazi, examining the impact of rumble strip installations in prevention of lane departure crashes in Maine. As an introduction, the line departure crashes compose around 72% of the total fatalities in Maine, also around 30% of the total crashes in Maine roadways. Maine DOT has installed 1,661 miles of rumble strips to prevent line departure crashes. So, this study explores the safety impact of the Maine's installed rumble strips in preventing lane departure crashes. As we can see in the figure, the three types of accidents who compose the lane departure crashes, which are head-on side sweep, rollover, and went off road, three of them aggregated compose the 72% of total fatalities in crashes in Maine. Also, in the table, we can see that Maine has installed two types of rumble strips, standard and sinusoidal, and it has been placed or classified at edge of the roads or at the center line of the roads. For interstate, there is only a standard in the edge of the roads, which is the most most mileage of rumble strip installed. Also, for the major collector, there is only a standard but placed in the center line. However, for arterials, they have both sinusoidal and standard rumble strips. So, the data collected for the study was 9 years of crash records, and the geometry of the rumble strip segments that were obtained from the Maine DOT Public Map Viewer, which is an online resource, and the Public Road Network of Maine from the Maine Office of GIS online catalog. The crash records are from 2012 until 2021 and include information as the type of crash, date of crash, location, condition of the road surface at the moment of the crash, type of road, road element identification, number of injuries, and type of injuries. For the rumble strips, there are variables as the type of rumble strip, standard or sinusoidal, classification, center, edge, or both, GR of installation, and the road element identifier. For the public road network, we had information about the AADT, the speed limit, the road element identifier, the number of lanes, and millage points. So, in the aggregated data, we can see that, for example, a when-off-road type of crash, 3 years before the installation of the rumble strips, around 1,600 crashes occurred, but 3 years after the installation of the rumble strips, around 1,500 crashes occurred. In the same way, for the different classes of roads, the other principal arterials, 3 years before the rumble strip installations, there were around 1,300 crashes, but after the installation, there were 1,240 crashes. So again, to assess the impact of the rumble strip in that reduction of crashes, we are proposing and following the methodology of before-after studies with the empirical-based approach to estimate the safety improvement of the rumble strip installations. The road elements and the crashes were aggregated by the element identifier, the AADT, and the speed limit. Also, with that information, safety performance functions were developed using the negative binomial model. And with that, we can calculate the impact of the installation of rumble safety in the reduction of the crashes using the empirical based approach, and then calculate crash modification factors for different types of facilities according to the aggregation of the data. So, because of this research is still in progress, as a preliminary results, we have found that the standard center rumble strips improve the safety of other principal arterial with 2 lanes. For this specific case, only AADT and the state of the surface at the moment of the crash were the significant variables. Also, for this specific scenario, when the road surface is frost, the crash modification factor is 0.8, meaning that there is a reduction of 20% in the crashes. As a remaining work, we have to extend this analysis for other groups of roadways based on the aggregation of the data, and also to analyze the effect of the edge rumble strips and the sinusoidal rumble strips. Thank you so much for your attention.